Hi everyone, today we're going to talk about using algebra to evaluate limits of polynomial and rational functions at selected points. Get ready to unlock the power of math together. Let's dive right in. So here we're going to go ahead and evaluate some limits. So you have the square root of 81 minus 3, and that gets you 9 minus 3, which we know is 6. So here we're just practicing how to evaluate. Our next, we have the square root of 1 minus 3 over 1 minus 9, which is 1 minus 3 over negative 8, which is negative 2 over negative 8, which simplifies to 1/4. And in number 3, you have the square root of 9 minus 3 over 9 minus 9, which is 3 minus 3 over 0, which we know is 0 over 0. Now, our resulting fraction of 0 over 0 is described as having an indeterminate form. Now, in that indeterminate form, right, you can't determine the limit of a function with 0 in your denominator. So again, remember from our previous lesson, when we know that direct substitution is not possible, we were typically going ahead and we were factoring. Now, when there's no factorable expressions, another technique that we can try is to rationalize. And what it means to rationalize is you're multiplying by the conjugate of that radical expression. So remember, it looks exactly the same, however, just a slight difference in our signs. One's positive and one's a negative. And the most common sort of way that you remember the conjugates is when we did our factoring of difference of perfect squares. So again, here is the same question from number 3. We know that we're going to get 0 over 0. We do not have any possibilities of being able to factor that expression, so we're going to multiply by the conjugate. So you're going to look and see where you have that radical, and it is the square root of x, and you have 3. So you have the square root of x, and you have 3. You started off with a minus, so you're going to have a plus here that you're going to multiply. That's the conjugate. So square root of x plus 3. Okay. Now when you get the limit here, as x approaches 9, what we're going to go ahead and do and multiply is here in our numerators. We're going to look and compare to see how we're going to square those to get those conjugate answers. So we're going to take our first term, and we know that that answer would have gotten us that squared. And you're going to have a minus sign. And we're going to take our second term, which was our 3, and we're going to go ahead and square it. And then we're going to multiply the denominator. And you can just leave it as x minus 9, parentheses, and the square root of x plus 3. Because at some point, probably you're going to have some term that is going to go ahead and cancel. So we have limit as x approaches 9. You have x, and then you have a minus 9. And you're going to just write again our denominator here. Now you're going to notice that our x minus 9s are going to go ahead and cancel. So you have the limit as x approaches 9, and you have a 1 in the numerator, sort of as your placeholder, and then you have the square root of x, and then you have plus 3. So now you have the ability to be able to go ahead and substitute that value in. So you're going to have 1 over the square root of 9 plus 3, which we know is 6. Okay, here we go. Number 4, first off, again, you're going to go ahead and substitute. So you have 0 over, you have 0 plus 9 minus 3. So you get square root of 9 minus 3. This is 3, so you get 0 over 0. So we would normally say, okay, well, let's try to factor. So you cannot, so you're going to go ahead and rationalize. So now your radical is in the denominator. So you're going to take the square root of x plus 9, and we're just going to change this minus 3 to a plus 3. So that's how we're going to change those signs to get our conjugate. All right, so when we do this, we're going to have the limit as x approaches 0. We're going to multiply. So we're going to have x times the square root of x plus 9, and then we're going to add 3 to it. And then look at our denominator. Take our first term, which is the square root of x plus 9. We know that would have been squared. You're going to have a minus. You're going to take your second term, and that's going to be squared. So as you simplify, you're going to have, let's just keep it as x and square root of x plus 9 plus 3. So you're going to have x plus 9 and then minus 9. All right, and then you're going to have, let's see, our 9s are going to go ahead and cancel. So you're going to have x, and then our expression in the numerator, and then x. You're going to notice that those x's will cross out. So what we're going to have is the square root of x plus 9, and then you have the plus 3. So now what we're going to do is we're going to go ahead and substitute that value in. So you have 0 plus 9 and then plus 3. So then you have the square root of 9. That is 3 plus 3, which we know is 6. Okay, so here in this question, again, substitute first. So you have 12 minus 12, square root of 12, square root of 12. This will get us 0 over 0. And again, can't factor. We'll go ahead and multiply by the conjugate. So our radical expression is in the denominator. So this minus will turn into a plus. So then you have, let's see, we are multiplying the top expression. Let's just keep it again in parentheses here. So you got your first term for the denominator that got squared, and then minus, and then the second term in the denominator, and that was squared. Again, we've got limit as x approaches 12. Let's leave the numerator as it is, and then cancel out, cross out that. So you're going to notice the x minus 12s will cross out. So you have just the square root of x plus the square root of 12. We're going to go ahead and substitute that value in, which will get us the square root of 12 plus the square root of 12. So when you have a square root of 12 plus square root of 12, that is 2 square roots of 12. This, let's say, we can simplify. So you have 2 times 2, which is 4 square roots of 3. Okay, so we have 4 again, square root of 4 minus, and then 4 minus 4. This is 0 over 0. All right, our radical expression. So square root of x becomes a x plus 2, square root of x, and then plus 2. So we have the limit as x approaches 4, and our radical expression in the numerator, and then 2 squared. You have x minus 4, square root of x plus 2. We will have the limit as x approaches 4, x minus 4, and then you have x minus 4 plus 2. Cross out. And notice that we keep carrying on that limit notation with us. So 1 over square root of x plus 2. As we substitute, we have 1 over square root of 4 plus 2. That is 2 plus 2, which is 4. Thanks for learning with me today, unlocking the power of math, one problem at a time. Don't forget to like and subscribe for future notifications on pre-calc videos. See you in the next lesson.